Welcome to the place where we gain knowledge through the lens of creativity. I am Aaron Dworkin, and this is Artful Science. Thank you again for joining me here on Artful Science. Today's show is Diamonds in the Sky, the Lucy mission and Soundscape. And my guest is Tom Statler, who serves as program scientist at NASA headquarters in the Science Mission Directorate's Planetary Science Division. Tom, welcome to the show.
Hey, Aaron, thank you so much for having me.
So, well, I am so excited and, of course, love the title from today's show. And a lot of our audience may not be aware of what the Lucy mission is at NASA. So could you kind of share what is the Lucy mission and what are its goals?
Sure. The Lucy mission is our latest planetary exploration mission. It's a robotic mission to fantastic objects in our outer solar system called the Trojan asteroids. And these are leftover building blocks from the formation of our giant planets, Jupiter, Saturn, Uranus, and Neptune. And they're in these fantastic orbits. They share the same orbit with Jupiter going around the sun, but they're not close to Jupiter at all. They're shifted off. It's like if you imagine the solar system sort of like a steering wheel on your car and put the sun at the center and put Jupiter at the top of the steering wheel. The Trojan asteroids are at 10 and 2. They're where you put your hands. So we're sending the Lucy spacecraft out as far as Jupiter, but in two totally different directions to see these leftovers from the formation of the giant planets. They're not like the asteroids that we have in the asteroid belt that everybody's heard of. Those are leftovers.
Yeah, that's what I was going to ask.
Those are leftovers from the formation of Earth and Mars and Venus and Mercury, planets like that. These are different materials. They're different leftovers. And if we understand things right, they're leftovers from all across the outer solar system that formed in a variety of different conditions and are probably almost completely unchanged for the last 4.5 billion years. So it's a fantastic opportunity to see these things up close. We've never done that before, to go places we've never gone before. And that's, what we do best at NASA.
Wow, absolutely awesome and amazing. And I really wasn't aware that there were kind of these other key, asteroids outside of, say, the asteroid belt. And is there a sense of what they'll be comprised of? So in other words, is there a sense that the planets and what has been formed on the outer parts of the solar system are really completely different materials than the core materials for the planets that were formed in the interior part of the solar system, like Earth?
Sort of yes, sort of no. We expect that all of these things are going to be a mixture of rocky minerals and ices. And the main difference, at least as far as we understand it now, between the things that formed closer to the sun and the things that formed farther from the sun, is that close to the sun, it was warm. And so things like water and carbon dioxide and stuff like that would have been in the vapor form because it was too hot. And so that's one of the reasons why the Earth and the other inner planets are rock and they're not ice. But if you go farther away from the sun, you reach a point at which water would have been solid rock. And there are places now beyond, Jupiter and beyond, where water as ice functions as a solid material. It's solid almost all the time. And so we expect that these things that form farther from the sun, and we've seen this in other places in the outer solar system, have a much higher mixture of water and carbon dioxide, all in the ice form, things that we would, on Earth think of as being liquid or gas, but out there, they are solid rock.
Gotcha. And of course, I'm always curious. I've, and always been obsessed, Star Trek, Star Wars, and all that. Any sense at all that there might be any detection of life on those asteroids at all, or an understanding of any building blocks?
So the chances of any of these asteroids having ever been habitable is pretty much zero. There's just no chance of that because they couldn't possibly have stayed warm enough to be conducive to biochemistry, right? But there's a very good chance that basic fundamental organic compounds, chemical compounds containing carbon, are going to be present there in some form. We also, one of the things we're looking to understand about asteroids in general, and one of the reasons that NASA is interested in sending robotic missions to the asteroids and the comets is to understand how stuff moved around in the solar system early in its history. I mean, now we've got this really, really orderly solar system where the planets are, in their orbits around the sun, but these orbits are very nicely nested. They never come close to each other. The planets never shift positions, which is good for us because that would be kind of embarrassing if it did. But indications are that early in our solar system's history, when the planets were young, there may have been some major shifts, especially shifts of the outer planets may have really moved around a lot. And that would have taken these leftover building blocks, these leftover bits, asteroids and comets, and shuffled them around in the solar system. So it's possible that the stuff that got delivered to the Earth when the Earth was young and that fell onto it and covered the surface might have been stuff that didn't form near where the Earth was. It might have formed further out. And so understanding how and when the Earth got the water that fills our oceans now, how it got and when it got the organic material that became the building blocks of life, that's still an open question. I'm not saying we're going to find, that's the spot, it's the Trojan asteroids that it came from, but it's all part of this fantastic puzzle that we're trying to figure out of how did our planets come to be the way they are? Why is Earth the way it is? Why are we here in the first place?
Right. Awesome. Awesome. Amazing. And also now that I'm kind of trying to visualize them, how big are they?
Oh, well, a variety of sizes. So asteroids are, there are millions, if not billions of asteroids in the solar system that range from, the size of your desk up to hundreds of miles across. The particular asteroids that the Lucy spacecraft is going to are asteroids that were discovered using telescopes on Earth. And so they're pretty big. They're tens of miles up to, close to 100 miles across, 100 kilometers across at any rate. So they're things the size of a big city or a small state, if you want to think about that.
Ah, wow. Okay. Got you. Great. So there is also something called the Lucy Soundscape. And as I came across this, and especially, of course, being a musician, was, absolutely filled with wonder. So what is the Lucy Soundscape and what's its purpose?
Well, I'm so glad you're interested in the Soundscape. The Soundscape is a way in which NASA has reached out to engage a part of humanity that we haven't really tried to engage with before, and that is musicians and composers. And what we've done, and I will unabashedly take credit for this because this was my brainchild, we have agreed within the mission team that there is a musical pattern that we've decided represents the mission, and it's just 3 notes. You can't see this, but I'm sitting at my piano right now, so I can play. Oh, my piano got a little excited right there. Those 3 notes are what we call the Lucy motif. And we've put this out there to the world of musicians and said, show us how you're inspired. Show us how this idea of exploration and studying the planetary fossils of our solar system, how does this inspire you? How does it motivate you? Coming from a completely different area of creativity, not scientific creativity, but musical creativity. How can you convey a message of inspiration, convey a message of mystery, of exploration, of knowledge, of understanding through music? And so we're engaging composers and musicians all over to create this body of music that represents their perspective on the Lucy mission, but all of that music is united because it all contains in some way.
That is, so it's truly, it's awesome and inspirational. And just wondering, kind of from your perspective, how do you view that connection between the arts and sciences? Why engage artists in this way in what is this inherently scientific mission?
Oh, there are so many parallels between art and science. And from my point of view, being a musician, an amateur musician and an out of practice musician, because it takes up a lot of time to do science. I love exploring those parallels, especially with music, There are ideas of symmetry and balance that come together. There's also just the similarity in kind of creativity, right? Because whether it's a musical idea or a scientific idea, it always starts with one germ, there's one thought, there's one idea, and then it's the creative process to grow that into something real, right? And if you're doing, I came of age scientifically in the time, and I was at the beginning of my career, a lot of my career, I was a theoretical astrophysicist. And this is at a time when, for a theoretical scientist, the coin of the realm was the sole author paper, right? You seize upon a problem that's never been done before, you figure it out yourself how to do it, you wrestle with it, and you find the answer and you publish it. And that's sort of the mark of achievement of a theorist. Science is different now. It's much more of a team effort, which is fantastic. But that notion that you take a subject, you decide what your medium is going to be. Is it going to be music or art or pastel or clay? Is it going to be pencil and paper theory? Is it going to be computation? Is it going to be a telescope, right? You choose your approach, you do the studies, and you produce a coherent statement. And you're producing a statement about the world that no one has ever made before. And that's the sameness, right, between art and science. You're trying to say something that no one has ever said in an original way, yet in a way that communicates to everybody really, really efficiently. Right? And I love that. And I was just remembering the other day, if you know Sunday in the Park with George, that the fantastic musical by Stephen Sondheim, the very beginning, right? It's an empty stage and George comes out and it's just all white. And he says, white, an empty page or canvas, the challenge to bring order to the whole. And that's what we're trying to do in science, and it's what we're trying to do in art.
I absolutely love how you have just blended that sensibility and that sense of connection and intersection of the arts and sciences. Absolutely beautiful and so true and inspirational. So a quick question about those three notes. Mm-hmm. How was your selection process? How did you arrive at those three notes?
So the story was a lot of fun, actually. So this happened at the encounter, the New Horizons spacecraft encounter with the Kuiper Belt object that is now called Arrokoth, which is the beginning of 2019. And I was there at the Applied Physics Lab in Laurel, Maryland, with a lot of other people in the whole New Horizons team. And it was quite an event. And NASA TV was covering it, and they were doing press conferences, press briefings. And at the start of each one of these, there was a little music that was played. And I listened to that, and I thought, well, that's kind of generic. That's just it's a track library that they bought. And I had a bunch of ideas in my head in rapid succession. One was, Lucy needs better music than that. The second one was, and I'm going to write it all. The third one was, that's not possible. The fourth one was, well, I wonder how all of my composer friends from years ago would have tackled this problem. How would they have treated it? And then there was just an instant from there to, let's just ask everybody how they would treat it. And from there, it was a bit of an effort. Now that happened. It was in 2019 during the government shutdown. So none of us could do our jobs. And I had a lot of spare time on my hand. And so I wasn't doing my government job. Had time to compose. And so I put together some homework exercises. I tried some different motifs, played around with different things. And I took it to my friends on the leadership of the Lucy team and said, hey, we need some good music. What do you guys think of this? And there was a long discussion over the course of several weeks. And eventually everybody kind of agreed that this one, the one that I played, was the best of the options that I'd come up with, and we would just go for it.
This is just such an amazing adventure, and also just such a great example and demonstration of the power of the connectivity between the arts and the sciences.
And technology too, because I really got to give a shout out to the fantastic people at NASA headquarters in the communications office and the social media team, because they made this happen, right? You can have an idea, and again, this is creativity in the 21st century. You can have a great idea, but you need a team of people to actually pull it off and make it work.
Totally. And that is absolutely awesome and a reflection of phenomenal leadership. Tom Statler, thank you for helping us gain knowledge through the lens of creativity here on Artful Science.
Thanks so much, Aaron.